In this video, we will learn how to make graphs of sine theta, cos theta and tan theta. And we will take inspiration from our unit circle. This is our unit circle where its radius is equals to 1, and we have marked some points on the unit circle. And in the last video we have we learned that our x becomes our cos theta and our y become our sine theta. So basically, if you are at this point, then at this point our x, this x was cos theta and y was sine theta. So at this point is cos theta comma sine theta. Cos x is cos theta and y is sine theta. So we will use the same circle, and now we have to make a graph, but this graph is from left to right. It was a circular graph here. Now we have to basically unwrap this circle into graph from left to right. Right? And this graph also has two things. One was theta was increasing, right? Theta was changing. It was 0, 90, and then theta was 180, then 270, then 360. Theta was changing. So now this theta we will put on the x-axis. And now the graph was another thing, the value of cos and sine. And that we will put on the y-axis. So we make a horizontal line. This is our x-axis, and let's say this is our start. And now we say that here in this, and this is our vertical line, this is our y-axis. And in the x-axis, we put our thetas, these thetas. So we say this is going to be our 90 degree, that means this 90 degree, this is going to be our 180 degree, then we will have 270, then we will have 360, then we will have 450, and so on. We can continue forever. Similarly, on the left hand side we will have negative angles. So we have minus 90 degree, minus 180, and so on. And so we are able to plot our thetas along horizontal line. Now we also have to plot our function. Function was on the circle, right? And we plot our function on the vertical line. So we say that, let's say we are talking about cos theta first. So cos theta can take maximum value of 1 and can take minimum value of minus 1. We can check that from this circle, that cos theta can take maximum value of 1 and minimum value of minus 1. So we say here is going to be our, here is going to be our 1 and here is going to be our minus 1. So this is basically the value of the cos theta, and this is the value of different thetas. Now we are ready to draw our graph. So when theta is 0, which is here, which is this point is theta is 0, because remember this is our theta and this is our sine function, cos function. So when theta is 0, then our cos is 1, because cos is x. So theta is 0, our cos is 1. So when theta is 90, our cos is 0. So at 90, our cos is 0. At 180, our cos is minus 1. When theta is 180, our cos is minus 1. So at 180, our cos is minus 1. And at 270, it's going to be what?
0.
Cos is going to be 0. So cos is going to be 0, and so it's going to be here. And then at 360, it's going to be what?
1.
1. So 360 is going to be 1. And how we progress from this point to this point is basically the same way, that it was a circular path. So we will take the same circular path here, because remember we are unwrapping the same graph. We can also maybe say right here 45, and we will know that at 45 it's going to be like some value of cos theta, which is 1 over square root 2, which will be somewhere here, right? So now we make like this kind of graph. It's like a semi-circular kind of graph, right? It has no sharp edges. It will just move in very beautiful wavy-like shape. It's like a wave. It's like a same circle, but we have taken this circle and now unwrap it on a horizontal plane, right? So now it's going to go up, and then once again I think it's going to go down, and so on and so forth. So the thing is this, that because after we reach here, like what will be cos 450? How can we find value of cos 450? Because after every 360 degrees, this circle repeats itself. So you can subtract 360 from it.
So we always go like this.
So it's always going to be like shh, because it will repeat itself. It's a periodic function. So we call such functions that repeat themselves after some values periodic functions. And both cos and sine are periodic functions, right? And their period is 360 because we have total 360 angles in a circle. So their period is equals to 360 degrees. After 360, they repeat themselves, right? Like from here to here, like this. Remember this diagram. This diagram, and this is like one 360 period. Now another 360 period will be repetition of the same diagram. You can just copy this diagram here, and you can copy this diagram here, because this diagram will be repeated again and again on every 360 degrees period. Make sense? So that's why we know that on 450 is going to touch here, because we can say 450 cos 450 is equals to cos 360 minus 450 is what? 450 minus 360 is what? Minus 360 is 90. So it's equal to cos 90. So basically, this is basically a one key important note, that cos theta plus minus 360 is equals to cos theta. Make sense? Because after 360 degree, it is repeating itself. That's why if we add, let's say, if I add 90 plus 360, my answer is 450. So basically, what happening with 90 will happen on 450. If I add 180 plus 360, my answer is going to be somewhere here, which is like 540. So what is happening on 180 will happen on 540. Make sense? So this is our graph of cos theta. Now we have to use the same principles. Yes?
How will it go there?
This way? Same way. So basically at minus 90, because this is the same shape we're going to repeat, right? So we're going to go down and we're going to go up, something like this. Oh, I think I messed it up a little bit, right? Because I don't think so. We have to. Yeah. See, I messed up. So this is incorrect. I think we have to somehow. Yeah, we have to here. We have to go here, and then we have to go. You know what I mean?
Yeah.
Now it's correct. So the same shape.
Minus 90 plus 360.
So you can say, yeah, minus 90 plus 360. So minus 90 plus 360 is what? Minus 90 plus 360 is 270. So yeah, you're right. See, both have the same result. You're right. You can do that because yeah. So now I have drawn the graph of cos theta. Now we have to draw the graph of sine theta, and for the comparison reason, I'm going to draw the graph of sine theta here, right? So, and it is very much similar to this. So basically, these two functions have lots of similarities in them. So now this is going to be my y-axis, and here is going to be my x-axis. Once again, this will be my 90 degree, this will be my 180 degree, this will be my 270 degree, this will be my 360, and this will be my 450, and so on. I can also write here pi by 2 because 90 is pi by 2, and this I write here pi because 180 is pi. I can write these angles also in radians, right? We know how to convert angles in radians. And this is going to be my 1, this is going to be my minus 1, right? Now at 0, what is value of this was the graph of cos theta, the above one. The below one is graph of sine theta, right? At 0, what is the value of sine theta is y. What is the value of y at 0? Because at 0, we are here. Y is 0. So that means we start from here, right?
Yeah.
This was our starting point. Otherwise, the graph looks similar, but you know, it is just a phase shift. We don't know yet what phase shift is. We will learn about phase shift later on. But it's just like graph has moved towards left or right, right? This same graph has moved. Like this point has come here. Otherwise, the graph shape remains the same. So we are here. What is about 90? At 90,
1.
so we have value is 1. So we will be here, right? At 180,
0.
our value is going to be 0. At 270, our value is going to be, because at 270 is going to be minus 1, right? Minus 1 is this one, right? Then at 360, our value is going to be 0.
Again, and then
So now let's draw this graph. So once again, we have to draw like a circle. It's a circular kind of thing, right? So we kind of basically take a foot, right? And we can't draw a straight line. It's not a straight line. Basically, it's a circle unfolding, right? So it's like a circle. This is the same circle as basically we are making this circle on a horizontal plane. So we come here, and then once again we continue our circular motion, and we come here, right? These are the points we have drawn before, and then we continue our circular motion. We come here, then we continue, we come here, and so on. Now this I like sine graph a lot because this is also periodic, but this looks like a like a proper wave. This looks like so this is periodic. Now it will repeat itself the same way, like one up and one down, right? So this is one period of sine graph, 360 period. Now it will continue doing the same thing for every 360 period. This will you can shift this here, we will get here. You can shift this here, we can get the graph here, and so on. So we continue like this, right? We go up, we go down, and so on and so forth. Make sense?
yeah.
So our sine graph and cos graph are both the same, but it has a phase shift. Now let's find out the phase shift. So as compared, if the sine graph let's start from the sine graph. Sine graph is here. Now if I move this thing here, like 90 degree, right? 90 degree, can I get the cos graph?
Yes.
That means they have a phase shift of 90 degree, right? So if I move this whole graph 90 degrees here,
Yeah.
this will become this point.
Yes.
Will I get the cos graph
Yeah.
or not? That means the phase shift is of 90 degree, because phase shift is how you move left or right a graph. Make sense?
Yeah.
So we know about the sine graph, we know about the cos graph. What about the tan graph? Now the important thing is that in case of sine graph, and the cos graph, our range is 1 to minus 1. Range is that the value that function can take is 1 to minus 1. In case of tan graph, our range is all the real numbers, and that's very amazing because it's a ratio, and ratio could be like very big and very small, right? Depending upon what value you choose. So our range is all the big number, because tan is theta is equals to sine theta and cos theta, and on the values where cos theta is 0, on those values tan theta is not defined, right? So basically cos theta graph is here. So cos theta is 0 on 90, cos theta is 0 on 270. On those values tan theta is not defined. So let's try to write tan graph also. So we don't have much of the board left, but we will try our best, right? So basically here we are x-axis, And we're not going to go detail the tan theta graph, but just a basic idea. And then we go here, and now because here cos is 0, here cos is 0. So I can draw this line here, because tan graph is going to be from here, so this point to this point, right? And the period of tan graph is 180. And afterwards, from here, this is 0 and this is 0. Tan graph will repeat itself. On every period of 180, it will be the same graph that will be repeating itself, right? And inside this period, the graph looks like this. That means it's never going to touch this line, but it's going to approach it. It's going to go near it, but never going to touch it. So it's going to be something like, not exactly, but something like this. Make sense? And then, and these values are like 1, 2, like 1, 2, 3. So it continue, tan theta is defined on all the real values. It can take all the real values. Tan theta could be like 700 for some value, right? And similarly, the same graph will repeat itself on this range. So on this range, once again, the tan graph will be something like this. Make sense?
Yeah.
So I hope that you will be able to learn something about sine theta, cos theta, and tan theta. And we're going to do a special video with lots of examples, maybe few hours of examples. And if something is not clear, then those things will be clear in our example video. So stay tuned. See you next time.